How do I evaluate functions? Okay, so you have to know PEMDAS. Please excuse my dear Aunt Sally. So P is parentheses, E is exponents, and then you have the arrow on the top of MD, which means multiplication or division from left to right, meaning if division was on the left, you would do that first. And then you have finally addition or subtraction from left to right as well. Let's look at some definitions. So we have a sub 1, that's how you read that, is the first term. A sub 2 is the second. A sub 3 is the third, and so forth. N is a term number. A n minus 1 is a term before, and D is a common difference. So we're going to look at three different things: functions, explicit form, and recursive form. So what is a function? It means that you have f of x equals, and then something. That's a function. We see f of x or g of x. And it just is the same as what you've been seeing before. F of x is really y. It's an output, and x is your input. All right, let's take a look at what is a natural number. Well, natural numbers are positive whole numbers. So when I evaluate a function given that f of 1, that's how you read that, all right, notice that that position 1 is the same position where you see x. You see how they're interchangeable? That just means that where you see x, put in 1. So I see an x right there, so I'm going to put in a 1. That's what it means. So evaluating a function is putting in the x into the function. Then follow, please excuse my dear Aunt Sally. So parentheses, 2 times 1 is 2. And then nothing else but add and subtraction. So plus 5 is 7. Okay, so that's how you evaluate a function. All right, now we're going to put in 2. So where I see x, put in 2. So it's going to be 2. I see an x, so it's 2 plus 5. Just please excuse my dear Aunt Sally. So parentheses first. So 2 times 2 is 4. And then there's nothing else but add in. So plus 5, which is 9. All right, now we're going to put in 3. So where I see x, put in 3. So it's going to be 2 and then 3. Plus 5. Again, please excuse my dear Aunt Sally. 2 times 3 is 6, and then plus 5. That's going to be 11. Last one, put in 4. So 2 times 4 plus 5. We're putting in 4, input 4. And the output you get is 2 times 4 plus 5, which is equal to 13. So the sequence is looking like 7, 9, 11, and 13. Can you see the pattern and give me the next number? Okay, what you're going to do is pause the video and see if you can evaluate that one. All right, now we're going to look at explicit form. So it's just a different method of writing it. So now we have a sub n, which means what? The nth term. And we have n, which means it's a term number. So you're going to evaluate this term. All right, so evaluate a sub n when n is equal to 1. So where I see n, I'm going to put 1. So this is a, and I see an n, so I'm going to put sub 1. Equals 2, parentheses, I see an n again, and remember n is 1, and write everything else the same. All right, now evaluate that using, please excuse my dear Aunt Sally. Parentheses first, 1 minus 1 is 0. Then multiplication, because that comes before addition. That's going to be 2 times 0, which is 0. Then addition, plus 7 is 7. All right, now we're going to do 2. So a, and then you see 2, equals 2. And now n is 2, so 2 minus 1 plus 7. Using, please excuse my dear Aunt Sally. Parentheses, 2 minus 1 is 1. Then multiplication, times 2 is 2, plus 7 is 9. All right, now we're going to put 3. Where I see n, we're putting 3. So a sub 3 equals 2. I see an n, so I'm going to put 3 minus 1 plus 7. Using, please excuse my dear Aunt Sally, parentheses first, 3 minus 1 is 2. Then multiplication, times 2 is 4. Then lastly, addition, plus 7 is 11. Last one, plug in 4. So a sub 4 equals 2, parentheses 4 minus 1 plus 7. Again, parentheses first, 4 minus 1 is 3. Then multiplication, 3 times 2 is 6. Then lastly, addition, plus 7 is equal to 13. Can you guess the next number if it's 7, 9, 11, and 13? Okay, so go ahead and pause the video and complete the example right below the one I just did. Now we're going to look at recursive form. Okay, so now we're given a sub 1. What does that mean? That's the first term. So the first term of the sequence. All right, and then we're given a n minus 1 means the previous term. So let's evaluate a sub 1. Well, they already told us. A sub 1 is 7. Boom, easy. All right, a sub 2, so we know n is equal to 2 because that's where n is 2, right? So a sub 2 is a, then we got n, which you know is 2, minus 1 plus 2. All right, so let's evaluate 2 minus 1 is 1, so that's a1 plus 2. What's a1? a1 is 7, so 7 plus 2 is 9. A sub 3, so now I'm going to put 3, so a sub 3 is equal to 3 minus 1, and then plus 2. So what's 3 minus 1? 2. So a sub 2 plus 2. So what's a of 2? Well, we know a of 2 is 9. So 9 plus 2 is 11. A sub 4, so I see, and I'm going to put 4. So a 4 minus 1 plus 2. So what's 4 minus 1 is 3. Then we have the plus 2. What's a sub 3? We know a sub 3 is 11. Plus 2 is 13. So my sequence is 7, 9, 11, 13. Can you guess the next number? And again, pause the video and do the questions just below it. What do you notice about all these three sequences? They're all exactly the same. So what does that mean? This is three different ways of representing the same thing. So you can write as a function in explicit form or recursive form. Again, three representations of the same sequence. These are three representations of the same sequence. So they can give you the question in one of three ways is what I'm saying. All right, you should have done each one of those. Do not do the last part, number 3. Let's practice.